Good evening and welcome to this lecture. Today we are on of introduction to atom. Um, what is an atom? Atom is considered to be the smallest part of an element that can take part in chemical reaction. This was the idea of an atom before early 19th century, and thereafter an English chemist known as John Dalton suggested a hypothesis known as Dalton's atomic theory. And this hypothesis uh, tend to change the previous knowledge about atom itself. Um, Along the line, Dalton's atomic theory is as stated. It is considered that an atom is the smallest indivisible particle. He also suggested that an atom can either be created or destroyed during the chemical reaction. Atoms of the same element are alike and different from atoms of different elements. J.J. Thomson, as shown on the screen, J.J. Thomson was the one that discovered the electron through his cathode ray tube experiment. He subjected a gas at a very low pressure and a very high voltage, and he succeeded in generating a ray moving from the cathode end of the tube to the anodic end of the tube, and he called that ray cathode ray. This discovery was made in 1897 by J.J. Thomson. The cathode ray suggested, which is also equivalent to electron, it travels in a straight line and can produce a mechanical effect. At the same time, Robert Millikan in 1909 performed his famous oil drop experiment, and he was able to determine the charge of an electron, and thereafter the mass of an electron was being calculated, which is 9.09 times 10 raised to power minus 28 grams. You can look at how infinitesimal an electron is. 9.09 times 10 raised to power minus 29 grams. It is pretty small. Millikan subjected an oil drop through an atomizer and a telescope to view it, and thereafter he was able to determine the charge to mass ratio of an electron. The proton at the same time was also discovered by J.J. Thomson. He used almost the same tube, but with different orientation. And at the end of the day, he was able to determine the properties of a proton. The proton also travels in a straight line. They can also produce a mechanical effect just like the electron, but then the difference is that they are positively charged. Neutron, on the other hand, came late. Why did neutron came late? Neutron was discovered by Sir James Chadwick. Neutron is neutral, it has no charge. So subjecting it to both a magnetic or electric field might not really have any effect on it because it is neutral. But then Sir James Chadwick in 1932 discovered neutron, which has a diameter of 10 raised to power minus 3 cm and a weight of about 1.6749 times 10 raised to power minus 27 kg. The properties of neutron, they are not deflected. Like I said earlier on, they are not deflected by magnetic or electric field. They have no charge. The mass of a neutron is equivalent to the mass of a proton. They have tremendous penetrating power. And the discovery of the nucleus itself. This was achieved by Sir Ernest Rutherford in 1991. He proposed the existence of a positively charged nucleus In his famous alpha particle scattering experiment, he bombarded the metal foil, platinum or gold, with a beam of fast-moving positively charged particle, that's the alpha particle, obtained from a radioactive source. The radioactive source generated the alpha particle, which is the helium here, and thereafter he discovered that the tin foil is subjected at the middle. He discovered that some rays passed through undeflected, some went back, and he was surprised. Thereafter, he was able to discover and to propose that the atom is made up of a central positively charged nucleus. Deductions from Rutherford. Rutherford suggested that an atom consists of a very small nucleus, and the larger fraction of the alpha particle that penetrated the metal foil suggested that the size of an atom is very large in comparison to that of the nucleus, which are very few and highly deflected beams were noticed. Hence, the nucleus is just a very tiny portion of a large atom, the size of an atom. Thereafter, another contribution made is that of Niels Bohr, as shown in this video. Rutherford has his own shortfalls, and Niels Bohr came up, suggested his own model of the atom just to take care of the shortfalls of Rutherford. Niels Bohr in 1913 proposed a new arrangement of the electron around an atom. According to this theory, the nucleus of an atom is centrally placed, and the electron in an atom revolves around the nucleus in a definite circular path known as the energy level. This energy level are designated as K, L, M, N, or N is equals to 1, 2, 3, 4 continuously. Thanks for listening. In our next lecture, we are going to consider also the shortfall of Niels Bohr's atomic model too, and we'll move on to that of suggestion made by people like the Schrödinger and Heisenberg. Thank you for listening, and key in for the next lecture.